This is Michael Garcia, and this is my machine learning program. I started with the demo that was made in class. From here, I was looking at the resources that were in the project. I went to Kaggle, found a World War II aircraft database that had 338 total unique values. When I downloaded it, it was a little bit messy, so took uh, I took the raw data, which was this, and I saved it as a Excel with macro enabled. I cleaned it up, separated it by commas instead of semicolons, um, placed it in individual cells, and then from here, I created a macro in Office scripts to automate the process so that I could put it all together no matter what format it came in. Um, then I started working on the code base. So the workflow operates like this. It comes in through preprocess, loads the data, selects the columns, cleans the numeric data, cleans missing rows. Then it takes the raw data and creates three new um, features for aspect ratio, size indexed, and number built. The number built was a raw data, and for the research I was doing, the number built needed to be um, transformed into a log. So I did that. Then I simplified the labels so that it would go through the raw data of primary role because it had several different options for primary role. And what it did was it went through and looked for any cells that contained fighter or bomber and then output fighter, bomber, other. It didn't fit the first two and then returned all that. So then it goes to features. This is where the features are actually put into a usable format for the machine learning algorithm to operate. And so it uses pandas and list and tuple, takes the model features, selects the model features, accounts for missing data, and then builds the feature matrix um, and drops the other out of the returned features. From features, we go to train. This uses the feature list as created by features.py. Does the x fit transform and then the x test scale transform, puts it into y for train for your outputs. During all this, I was incrementally doing tests. So I created a test for the process, a test for features, a test for train, and a test for predict. And then I ran tests, and what the run test.py does is it not only runs the test, but it also logs the output for the test, which can be seen in test data. And so what it does is the test data is logged with the test time or date and time, and then the results. It shows the command line I used, and then the results of the test. And this allows me to look at a glance what tests had been run, what the results were, what I needed to fix. It also gave me errors, so like if I ran a test and it was an error, like right here, it would say unbound local error, cannot access local variable, and then I would fix it. In my README, I have the instructions on how to use the repository layout, the tech stack, so what's in it, what uses it, or what's used inside the repository, how the pipeline works, which is how I just described it to you, and then it has the final step of the prediction. That's with after you train the model, it can make predictions. I have a simple setup in there for predicting something that I know what the outcome will be, or should be anyways. So I got the data preparation, the money, running the projects, and then I have this here, so you can take this and then copy paste it into your command line. Sorry, it's this one. All right. So it ran feature matrix shape, the target vector shape, class counts. So we have role class, fighter, bomber. So we have 106 fighter, 95 bomber. And it gives the precision of the predictions, the F1 score, and the support accuracy, the confusion matrix, and then it saves the model to model.pkal. If you want to run a test to see how the test is running, we could do this, control copy, paste, then it'll load the saved model, shows you the feature matrix, gives you pertinent information, confusion, and then uploads the newest run test automatically, the date and time. That is my submission for machine learning.